Hello everyone, this is THASNI from Department of Computer Science and Designing, and today we are going to see about the computer networks. And other in the networking, we are going to see about the network layer. Under that, we are going to see about the IPv4 addressing and subnetting. So first of all, what is I will have a question like there are millions of devices worldwide where we are going to communicate every second. So every device needs a unique identity, just like your home needs a postal address, right? So how we are going to connecting with the world? Like we have to, for example, postal address analogy will take. So the postal address analogy, the physical postal analogy, like every physical house has a unique postal address, and similarly for the every device connected to the internet has a unique IP address. For example, the structure of our address will be country, city, street, door number. Where the crucial part is without this unique address letters, data cannot be delivered. Here, the same similar way, the structure of IP address will be 192. It starts with like that, 192 dot. We call it as period, like a network block. Then we call it as a subnet, and we call it as a subnetwork. Then device, postman, and postal. The same like only capacity is 4.3 billion. The postal addresses are with the 32-bit system, and the function is IPv4 as postal system of the internet. So in the daily use, when you use IPv4, like for example, we are going to watch YouTube, sending emails, video calls, online gaming, downloading apps, everything, all are depend on a unique IPv4 address, right? So next, what problem does IPv4 solve? Actually, IPv4, what is IPv4 like? It is a 32-bit address protocol that uniquely and universally identifies every device connected to the internet. Like unique identity means each device gets one unique address. No two devices share the same IPv4 address at any time, and it enables the precise point-to-point communication. And the universal standard is accepted by every internet connected host globally, and OS agnostic, which is Windows, Linux, Android, all use IPv4 and the foundation of the global network. Next one is datagram routing. Device defines how packets travel end to end, like best effort connectionless delivery works hands in hand with the IP TCP for reliability. So, for example, we are giving a prompt like if every device in a unique IPv4 address and IPv4 only supports 4 to 3 billion address, where problem might arise as the number of internet connected device explodes. For example, you just think for 1 minute, like jot down your initial ideas individually, then share with your partner. Do they have any new perspectives? And you can discuss among the one point per group to the class. This is an activity you can connect through the for this. So actually, IPv4 address space and notation will be actually IPv4 uses 32-bit address space, which is a 2 into the 2 to the power of 32, which is a 429467296. The two common notation which is called as binary and dotted decimal. Binary will be like 0110101 zeros and ones, and dotted decimal will be 117.14929. It might vary. So each octet we call it as byte, okay, and it consists of 8 bits, which values from 0 to 255, and total 4 octets separated by the dots. That dots we call it as period. So we have set of quick rules like no octet should be greater than 256. So for example, 301 is invalid one, and there is no leading zeros. It is 4041 is invalid. Exactly 4 octets is required. Yeah, classful addressing, like we'll address like the address space was originally divided into 5 classes based on the first few bits. Like class we segregate into class, then the first bits one octet, first octet block size, then use, like that. Next, classless address, we call it a solution to the address definition, which is classless internet. Domain routing, we call it a CIDR. There's no fixed classes, and blocks of any power of 2 size can be allocated. So the notation will be x dot y dot z dot t slash n. Like any address in the block with x y z dot t, and n will be the prefix length. which has a number of networks. Example 205.16.37.32/28, which is a 28 is the network bits and 4 host bits 2 into the power of 16 addresses. And there are three restrictions on the CIDR blocks, which is address must be contiguous, block size must be power of 2124, 8, 16, and first address must be evenly divisible by the block size. Next, how IPv4 actually works, like from the source to destination, like datagram header will be 20 to 60 bytes plus data. So the source to destination will be the unchanging 32-bit origin and target's IP, and TTL, which is a hop count decremented by every router if it's hit. If it hits zero, the packet is killed to prevent infinite network loops. And the protocol, it tells the receiving network layer where to hand the data. Okay. So the structure will be like a version and header length, which is specifies IPv4 and it dictates the header length minimum to 20 bytes. And the total length will be defines entire packet size up to 65535, and it is differentiated into services like TOS, like any an 8-bit priority tag that dictates if a packet will get maximum throughput or minimum delay through the during congestion, and it is differentiated into like service type and differentiated service. Thank you.